The second thing that we're going to discuss is the material according to their electrical conductivity. So you have to know that in nature, material is divided into 4 categories according to their ability to conduct electricity, which means that let's discuss, for example, the insulators. So the first material that I'm going to discuss is the insulator. So insulators, they are the material that they do not allow electrons to move freely in it. And why is this? Because the electrons, which are the valence electrons, in order for them to participate in the conductivity, they have to have a certain amount of energy, which is equal to the energy gap. Now, I'm not going to get into details here because this is like somehow basic it's going to be. For these electrons to have, to be considered as a conducting electrons, they have to have a certain amount of energy, which is equal to the energy gap, which is the energy needed for the electrons to become in the conduction band. Now, the energy gap for the insulators, it's extremely high in such a way that even if I'm going to supply an insulator, let's say a wood, so wood is a type of insulator. So if I'm going to give this piece of wood energy by connecting it to a circuit. So if I put here the piece of wood here and I'm connecting this piece of wood to a cell, let's say that this cell, I can control the voltage. So as I increase the voltage, as I increase the energy which is given to this wood, these electrons which is in the wood, they will not be able to be a conducting electron. So the wood will burn and the electrons will not have the amount of energy needed to participate in the conductivity. So insulators, yes, they have electrons, but these electrons are not conducting electrons. This is what you need to know. Now, if I want to charge an insulator, yes, I can charge an insulator. For example, you can take the balloon and charge it by rubbing it to your head. But what will happen is that, let's say I'm adding electrons to this balloon. So what will happen is that the electron which is added, let's say I'm rubbing it here. So I rub this balloon here. So what will happen is that the electron will stay localized, which means that this electron added to the insulator, it will remain in its place. And if you want the evidence of this, if you try to stick this balloon, let's say to the wall, then this balloon will not stick on another side, which is the other side which you did not rub. So because the electrons are on the side where you rubbed it. Okay, so insulators, electrons are not free to move in an insulator. The second thing that you have to know is that if I charge this insulator, charges are localized in their place because they can't move. Now, the second type of material, it's the semiconductors. The semiconductors, basically, yes, the electrons are binded to the nucleus, and the valence electrons, they can't be conducting electrons unless they have a certain amount of energy, which is equal to the energy gap. But the thing about semiconductor is that the energy gap, which is between the conduction band and the valence band, so usually the valence electrons are in the valence band. For these valence electrons to be conducting electrons, they have to have enough energy, which is the difference between the conduction band and the valence band. So this energy gap, so this is the conduction band. So this energy gap in a semiconductor, I can supply the material with this amount of energy without losing the properties of this material, which means that without burning or destroying this material, like what's happening for a wood, for example, or for a rubber. So a semiconductor can act as a conductor if I give the electrons a certain amount of energy equal to the energy gap, which means that the good thing about a semiconductor is that the motion of the electrons can be controlled. And that's why semiconductors are used in electrical circuits, which is in the electronics, for example. So in an electronic, like a cell phone, it works on the binary system, which is the 0 if there's no current, the 1 if there is current. So of course, I'm not going to add an insulator to this circuit because the insulator will not allow the electrons to move, even if I'm giving it energy. And I'm not going to put conductor in the electronic devices because I don't want the electrons to be moving freely. I need to control the motion of this electron. So that's why semiconductors are used in electronics. Now, if you go to the conductors, which is the third type of material, then the electrons in the conductors, they are free to move. So even valence electrons, they are considered to be conducting electrons because there's no energy gap. So in the conductors, the conduction band, so this conduction band, it overlaps with the valence band. And I'm going to discuss this in another videos, in another more advanced videos, which means that these electrons, they can move freely. They don't have any gap. They don't need any amount of energy for these valence electrons to become conducting electrons, which means that electrons are not binded to their atoms. They can move free. So these electrons can move freely, and this is what we call conductors. Now, if we talk about superconductors, like some types of metals, they are superconductors, but they act as superconductor at a certain temperature. This temperature is called the critical temperature. Okay, so this critical temperature, at this temperature, the lattice vibration of the atom is going to be null, which means that the resistivity is going to decrease, and that's how the conductivity is going to increase. We say it shoots infinity. So this is what's the difference between the superconductor, the conductors, the semiconductors, and insulators. So in this lesson, we will be discussing how to charge a conductor and how to charge an insulator.